Hello students, today in this video we'll again see a problem on Laplace transform. Here they have asked to find the Laplace transform of the function defined by f of t equal to sin t when t varies from 0 to pi and the value is 0 when t is greater than pi. Okay, so it means we need to find the Laplace transform of this function f of t where f of t is given in this format. Okay, so first let us write the general formula of the Laplace transform of f of t. So by definition, Laplace of f of t is nothing but integral 0 to infinity e power minus st f of t dt. So this is the general transform. This is the general formula of Laplace transform. Here as you can see here the t varies from 0 to pi and the another varies from pi to infinity, right? So I'm going to split this interval. So according to our given problem, one interval will be from 0 to pi e power minus st f of t dt and the another interval will be integral pi to infinity e power minus st f of t dt. Okay, now coming back to the problem, in the interval 0 to pi f of t value, we need to check from the given problem. So in the interval 0 to pi f of t, here the interval, here it is given in the interval 0 to pi. So here in this interval 0 to pi, f of t value is nothing but sin t. So I'll write here sin t in place of f of t, I'll write sin t. So in the interval 0 to pi e power minus st, f of t value is sin t. No, f of t value is sin t. So I'll write sin t into dt plus in the interval pi to infinity e power minus st, f of t value in the interval pi to infinity is nothing but here this interval. So in this interval f of t value is 0. So in the interval pi to infinity, now I will put f of t value as 0. Okay, so this is into 0 dt. So this is equal to integral 0 to pi e power minus st sin t dt plus 0 into e power minus st is 0. So if we integrate the term, the whole term will be equal to 0. So this is 0. So therefore only the first interval remains. So this is integral 0 to pi e power minus st sin t dt. Only this interval remains. Now what we need to do, we need to integrate this term, right? So we can integrate this term using Bernoulli's. Okay, using the Bernoulli's formula we can integrate this term. Okay, so if we can integrate using the Bernoulli's formula, and also there is one more formula. Okay, there's one more formula to integrate the term. Okay, so the formula is, we know that integral e power ax sin bx, this is one of the formula of the given problem in this format. Okay, so we know that integral e power ax sin bx dx is nothing but e power ax divided by a square plus b square into a sin bx minus b cos bx. This is one of the formula we know, okay, of this format. Okay, so we know that integral e power ax sin bx dx is nothing but e power ax divided by a square plus b square into a sin bx minus b cos bx. Otherwise, you can also use the Bernoulli's formula and you can find the value. Okay, it's your wish. So either you can apply the Bernoulli's formula, otherwise you know the formula, you know this formula, you can apply directly. Okay, it's your wish. Now I'm going to apply this formula now. Okay, in this interval. So here I can see here the in place of here the integration is with respect to dt, right? So I'll change this interval with respect to t. Okay, in place of x I'll put t. Okay, okay, wherever there were x I have substituted as t now. Okay, so next I'll write the value of a and b. So if you compare these two equations, you can see here the value of a is minus s and the value of b is 1. Here the value of a is here minus s sin bt. So here the value of b is, if you compare these terms, here the value of b is 1 according to the problem. So I have written a equal to minus s and b equal to 1. If I substitute in this interval, I'll get L of f of t. So this is equal to e power e per at. A value is minus s. So minus st divided by a square. So minus s, if I square, it will be s square plus b square. B value is 1. So b square will be 1 into a. A is minus s. Minus s sine b is 1. So 1t minus b. B value is 1 cos bt. B value is 1 again, so it will be t. Okay, so directly I have applied the formula, and the limits which are given in the problem is 0 to pi. So I'll write here 0 to pi, the limits. Okay, so this will be equal to e power minus st divided by s square plus 1 into, this is minus s sin t minus cos t. Here the limits are 0 to pi. Okay, so first, so the limits should be applied in place of t. No, so we have integrated with respect to t, right? So here the upper limit and the lower limit will be substituted in place of t only. So in place of t only we need to substitute. So what I'm going to do is 1 by s square, I'm taking it outside. So if I take 1 by s square plus 1, if I take it outside, then the terms which remains are e power minus st into minus s sin t minus cos t and the limits are 0 to pi. E power minus st I'm going to multiply inside here as well as here. Okay, so if I multiply, this is 1 by s square plus 1 into minus s e power minus st into sin t minus e power minus st cos t, and the limits are 0 to pi. Okay, now I'll substitute the limits, upper limit and lower limit now. Okay, if I substitute the upper limit and lower limit in place of t, I'll get 1 divided by s square plus 1. So in place of t only I have to substitute pi value, right? So first I'm going to substitute the upper limit value. Okay, wherever we have t, I'm going to substitute it as pi. So I'll get minus s e power minus s pi sin pi minus e power minus s pi cos pi. Okay, so upper limit pi I have substituted in place of t. Similarly, I have to substitute the lower limit 0 also in place of t. So to substitute 0, I'll put minus here, minus. Now I'm going to put, in place of t, I'll put the lower limit 0. So in place of t, if I put the lower limit 0, I will get minus s e power minus s into 0 is 0 into sine 0 minus e power 0 cos 0. Okay, this is the value I'll get. So this is equal to 1 divided by s square plus 1 into sin pi value is 0. So 0 into this term will become 0. So the first term is 0 minus e power minus s pi into cos pi value is minus 1. Okay, minus, then coming here, sin 0 value is 0. So 0 into anything is 0. So 0 minus e power 0 is 1. Cos 0 is again 1. So 1 into 1. Okay, so this is equal to 1 divided by s square plus 1. This is minus into minus plus. So you'll get e power minus s pi and then minus of. This is minus 1 into 1 is minus 1. So this is equal to 1 divided by s square plus 1 into e power minus s pi plus 1. Okay, so this is my final answer. Therefore, the Laplace transform of the given function is this part. Okay, hope you understand the problem. Thank you so much for watching.